Hello everyone. In this second session on significance tests about hypotheses, we will be looking at how errors crop up when we do these hypotheses, and we'll try to understand them. So, before we start and look at those errors, let's have a quick recap of the terminology we have learned. We'll talk about a significance test, its relevance, the meaning of hypothesis, and one simple example of hypothesis writing too. Okay, so let's talk about the significance test. Now, remember, significance test, or test for short, is to make some statistical inferences about the population. We use a sample data and use it as to make sure that the claim or the hypothesis about a population which is being made is correct or not. And then we use data to summarize these evidence. The most important part is that the assumptions are that the data we used is randomly generated. So there is unbiasedness. And then we talk about the hypothesis. So in the significance testing, it has two hypotheses. One is the null hypothesis, and the null hypothesis is denoted by H sub 0. It is that established status quo. We assume it is to be true, and we always denote it by an equal. It has an equal sign involved. The alternative hypothesis is the one which is challenging the status quo, and it is the one which says the parameter falls in some alternative range of values. The way we write the null and the alternative hypothesis. The form of null hypothesis is H0 parameter equals the hypothesized value. Remember, when we have a null hypothesis, we will have to have an equal sign, and the parameter is important. We work with parameters. That means we are working with population. The alternative hypothesis is when the parameter is strictly greater than. That means we have a right tail test. Or if the parameter is strictly less than the hypothesized value, that means we're talking of a left tail test. And the other final scenario is when the parameter is not equal to the hypothesized value. That means we have a two-tail test. Let's quickly do this simple example we have done before. That the mean area of apartments in a new development is advertised to be 1250 square feet. A tenant group thinks that the apartments are smaller than advertised, and they hire an engineer to measure a sample of apartments to test their suspicion. As I have talked earlier, when you're reading the problem, highlight the very important words. The very first word, mean, is a giveaway that we are talking with the parameter to be a population mean. That means we are looking at mu's. So automatically, the moment you know what parameter is, go ahead and write down the mu's, and next to the null hypothesis an equal sign, because after that is a value we have to put. Okay, so it says mean area of apartments in new development is advertised to be 1250 square feet. There it is. 1250 is the value. Okay. Now the alternative hypothesis will also have 1250. The only thing is, what would go in between the mean notation and this number 1250? For that, once again, we go back and read the problem, the second sentence. A tenant group thinks the apartments are smaller than advertised. That's the key. That means the alternative hypothesis is a strictly less than symbol. Okay, now let's look at the analysis of it. And the analysis part, the idea is that when we do our testing, we are basically doing a test of the null hypothesis versus the alternative hypothesis. And we take a sample data to test our claim. If the sample data provides a very strong evidence that the null hypothesis is false, that means we will reject the null hypothesis. That's the first statement. But if the sample evidence does not give us such a strong evidence, we say we will fail to reject the null hypothesis. So two possible things to link: rejection of the null hypothesis or fail to reject the null hypothesis. Okay, now when we are making our analysis, definitely errors can crop up, and these are two kinds of errors, and those are called type 1 and type 2 errors. So we test our sample data, whether the main idea is whether the null hypothesis should be rejected or it should be failed to reject. So as a result, when we're making these, hypothesis testing, we're using some kind of a test to look at the sample data. We might actually end up making a wrong analysis about this parameter. That means it will lead us to two kinds of errors: a type 1 and a type 2 error. Okay, these two types of errors which are made, and we're going to create a little table which will make our life simple. On the row side, we will say fail to reject the null hypothesis, or we reject the null hypothesis based on our analysis. In reality, when we go from the column wise, the last two columns is telling that the second column says, oh, in actuality, the null hypothesis was true. Okay. The last column says, no, the null hypothesis was actually false. So when you create this kind of a table, the intersection of the null hypothesis being true and the rejection of the null hypothesis takes us to a type 1 error. So what basically it means is when a null hypothesis actually is true and we still end up rejecting the null hypothesis, man, oh man, we are in big trouble here. So we're going to have a type 1 error. On the other hand, if the null hypothesis is false and we say, no, everything is good and ready to go, that means we are failing to reject the null hypothesis. Again, we are having some little issues here. That means we have a type 2 error. So my suggestion is this is a very important slide because it tells us specifically this matrix, guys. This matrix is an important matrix when it comes to type 1 and type 2 errors. Okay, so let's look at how we are going to apply this kind of a matrix or a table form in our problems. Now, this is an example of the US Bureau of Transportation Statistics. It reports that for 2005, 78.6% of all domestic passenger flights arrived on time, meaning within 15 minutes of the scheduled arrival. That's how they think. Okay, suppose that an airline with a poor on-time record decides to offer its employee a bonus. If in the upcoming month, the airline's proportion of on-time flights exceeds the overall industry rate of 78.6%. Well, so here is the scenario, guys, where this airline company, which is known to have poor time records, says, okay, guys, if you start getting your flights on time and it is more than the overall industry rate, we are going to definitely reward you. Okay, so here is the null and the alternative hypothesis. The first thing, guys, is when you're reading a problem, when you don't see the word mean, that means, and you see only percentages, that's a proportion. You see the word mean, then you have to be careful and read it again. So here we do not see the word mean or average anywhere. Rather, we actually see the word proportion literally popping up. So that tells us the problem in hand we are working is with proportions. Okay, now the proportions will have some value. And the value is given from the very top and the very last line, which gives us 78.6. So if it's a null hypothesis, the proportion should equal 0.786. Once again, keep in mind that when we write it down in the problems, we write it as a percentage, but when we solve it, we write it as a decimal number. Now this airline says, oh guys, you do a good job, you get your proportion of these flights more than the industry rate. That's what we're looking at. So that's their alternative hypothesis, that the proportion of their flights is going to exceed the 78.6%. Okay, so what kind of errors can come up here? Let's describe a type 1 error and what are the possible consequences. Now remember, when you're doing these problems, what my suggestion is, type 1 means the H0 is true, okay, and the first one is fail to reject and the last one is reject. A type 1 error, guys, keep in mind, is the scenario when the null hypothesis is true but we still reject the null hypothesis. That is type 1 error. Okay, so that means what is going to happen in this scenario? This airline company is thinking, so the airline company says, oh, we are going to reward you because you actually, the sample data which they took, that actually ended up exceeding 0.786. So they ended up actually giving their employees a reward because they thought it increased, the proportion of their flights increased. But in reality, it did not increase. So what is happening is they are rewarding their employees even though the proportion of flights did not exceed. So that's a type 1 error. Let's look at a type 2 error. In a type 2 error, guys, that means H0 is false. That what is going to happen is, remember, the first, the second row is fail to reject, and the last row is reject the null hypothesis. Okay, now in this one, guys, what's going on is, here we're looking at a type 2 error and we would discuss the possible consequences. So what is happening is the H0 is false. What H0 false means what? The airline actually was having their flights exceeding the rate of 78.6%. It was actually happening. But what happened? The company said, no, you guys are not doing it. And as a result, they did not reward the hard work of their employees. So, so that kind of error is called a type 2 error. So type 2 error means the airline employees were not rewarded. In fact, actually they deserved it. Okay, that means there was sufficient evidence that the airline's proportion of on-time flights exceeded the overall industry rate of 78.6%. Now let's talk about some probabilities, guys. We're in a probability class, so we need to know what error probabilities can come up. Now, this is the table again, which of the two types of error. For the two types of error we see above, the type 1 and the type 2, the probability of making an error is described in the form. So if the null hypothesis is true, then the significance level alpha, that's what we call, it is the probability of making a type 1 error. That means the null hypothesis is true, but we still reject the null hypothesis, and the probability of making that is a type 1 error and is called alpha. Whereas beta, it is the probability of making a type 2 error. So when we are performing these hypothesis testing, we generally want to minimize these alphas and betas. That means we want to minimize the errors which can happen. Let's look at an example. Now, Pizza Hut, after test marketing a new product called the Bigfoot Pizza, concluded that the introduction of the Bigfoot Pizza would increase, it's a conclusion here, increase its mean percentage sales by more than 14%. Okay, this was done in April 12, 1993. This conclusion was based on recording sales information for a random sample of Pizza Hut restaurants selected for the marketing trial. Now let mu denote the mean percentage sales for all Pizza Hut restaurants. Okay. We would like to first write down the null and the alternative hypothesis. As the word mean has popped up, that means we are having the parameter mean here. And it is 0.14, guys, not 14%. So it's 0.14. Yeah, it's 0.14. Okay, so it says the mean percentage sale. What is their conclusion? That it has increased by more than. The word more than means you're having a null hypothesis of mean greater than 0.14. Whereas the, alternative hypothesis, the null hypothesis will have an equal sign. The mean percentage sales is 0.14. Okay, let's look at how it is relevant in terms of type 1 and type 2 errors. Okay, is the Pizza Hut's conclusion consistent with the decision to reject H0 or fail to reject? Now remember, conclusion, what they made the conclusion is that their mean percentage sales has increased. So it is consistent as conclusion with the last sentence says it was based on recording sales information for a random sample of Pizza Hut restaurants selected of the marketing trial. Now, that's their conclusion, remember. So if the Pizza Hut is incorrect in its conclusion, now, is the company making type 1 or type 2 error? Okay, let's go ahead and make a little table, okay? H0 true and H0 false. Now, true means that there has not been an increase in the percentage sales. But what was their conclusion? They said no, our mean percentage sales have increased. So if their mean percentage sales have increased, what does that mean? That means they will reject the null hypothesis, right? So this is a type 1 error. Now, let's look at this fact. Let's read the question again. If the Pizza Hut was incorrect in its conclusion, so the thing we have to keep in mind is the conclusion is their mean percentage sales have increased. So as their mean percentage sales have increased, but this has not worked. Do you see that here? The mean percentage sale did not actually increase. So what we can say is that the null hypothesis was actually true, and hence we ended up rejecting the null. So we ended up actually doing the rejection of it. So this basically is the classic scenario of that the null hypothesis was true, but they based their decision on, their means percentage sales have increased. So they say, hey, this is going to happen. But their conclusion was not right, and hence a type 1 error. One more example, guys. During an angiogram, heart problems can be examined via a small tube, a catheter, threaded into the heart from a vein in the patient's leg. It's important that the company that manufactures the catheter maintains a diameter of 2 millimeters. Each day, quality control personnel makes several measurements to test the hypothesis that the null hypothesis that the mean, that is the the average these catheters are made is having a diameter of 2 millimeters against it is not equal to 2 millimeters at a significance of level alpha 0.05, that means 5%. Now, if they discover a problem, they will stop the manufacturing process until it is corrected. So here is in front of us is our hypothesis. So the moment you look at this one, the question is, what the question says is this one-sided or two-sided test in the context of the problem? And why do you think it is a problem? First of all, it has been given to us. The problem already gives us the null and the alternative. And the not equal sign says this is a two-sided test. Now, in the context of this problem, what do you think is? It is, if they are too big, then they won't fit through the vein. And if they're too small, they will not probably work well. So we are basically in a problem over here. And now let's look at another kind of questions which can come. Explain this in context. What happens if the quality control people make a type 1 error or a type 2 error? So let's see what happens if the quality control people make a type 1 error. The catheters are rejected. Now, type 1 error means the null hypothesis is true. That means the manufacturing company is exactly making the diameters right, but they reject it. So what is going to happen? The manufacturing process is needlessly stopped when there was no need of doing it. Now, on the other hand, what happens if the quality control people make a type 2 error? That means the catheters which were being produced were not being produced with the correct diameter. And what happens? You're putting the people who would be receiving it in lives in danger. So the catheters are not meeting the specifications and are still allowed to be produced and sold. Thank you, guys.